Hi, are you ready to take your microservices architecture to the next level? In this video, I will explore some powerful architecture patterns that can help you improve the security, scalability, and efficiency of your microservices. So whether you are a seasoned developer or just starting out, buckle up and get ready to learn how to supercharge your microservices architecture. Let's start with API Gateway. API Gateway acts as a layer between your application and backend services. It's a single entry point for all incoming requests from clients to the microservices. It abstracts the details of backend services and routes incoming requests to the appropriate backend service, which promotes modularity and scalability. It provides several benefits that can make your microservices architecture more secure, scalable, and easier to manage. Firstly, an API gateway can centralize your authentication and authorization logic, which means you can secure your APIs and data more effectively. Instead of having to manage those details in each service, you can handle them in one place. Secondly, an API gateway can offload load balancing and routing to backend services, which can help you scale your application and distribute incoming requests. By balancing the incoming request load across backend services, an API gateway can prevent overload and keep your application running smoothly. Thirdly, an API gateway can abstract the details of backend services and route incoming requests for more modular architecture. This can help you to create more simplified and organized code, as well as make it easier to update and maintain your services. Another benefit of API Gateway is analytics and monitoring. By providing valuable insight into the application usage and performance, an API Gateway can help you to optimize your services and improve the overall user experience. Finally, an API Gateway can generate and manage API documentation, which can be a significant time saver for developers. With clear and concise API documentation, your team can more easily understand and use your microservices architecture. Let's take an example of an e-commerce platform. The platform has multiple services, such as an inventory management service, a payment service, and a shipping service. An API gateway can be used to route incoming requests to the appropriate service, such as order creation requests to the inventory management service, a payment processing request to the payment service, and a shipping request to the shipping service. This can help to simplify the architecture and improve scalability and performance. Now let's talk about event sourcing. Event sourcing is a powerful architecture design pattern, useful especially for systems with high data integrity and auditability, such as financial systems. It emphasizes capturing the history of an application state as a sequence of immutable events. Instead of persisting the current state of an application in a traditional database, event sourcing captures every change to the state of the application as an event, and then persists those events in database or message queue. Event sourcing provides many benefits, including ability to recreate application state by replying events to recreate the state of your application at any point of time. It's helpful for debugging and resolving issues. Improved auditability by capturing and storing all changes as a sequence of events to track the history of your application and identify the errors or changes that occur. Let's take an example of banking application. The application uses event sourcing to store all transactions as events in a log. The application can then replay the events to recreate the state of the application at any point in time. This helps to ensure the data integrity of the application and provides a clear audit trail. However, implementing event sourcing in microservices requires careful design and implementation. Here are some considerations. Design events carefully. Each event should represent a meaningful change in your application state and be designed to be consumed by other services. Store events scalably and reliably by choosing a storage mechanism that can handle large volumes of events and ensure high availability. Implement a reliable and consistent way to publish and consume events. Choose a messaging or streaming system that ensures delivery and provides order guarantees. Address eventual consistency challenge. Consider compensating transactions or quorum-based systems as events are stored and processed asynchronously. Now let's move on to CQRS, Command Query Responsibility Segregation. It is an architectural pattern that separates read and write operations of an application into different models. This separation allows for faster and more efficient data retrieval and updates. In microservices architecture, CQRS can be a powerful tool for managing large systems by developing and deploying each service independently and optimizing each service for specific task. This results in better fault tolerance, easier scaling, and improved efficiency of data retrieval and update operations. For example, an e-commerce platform can separate product listing and order processing into different services, ensuring faster query response times and improved scalability. However, implementing CQRS in microservices architecture can also present some challenges. It requires more services and communication between them, which can add complexity into the system. Designing the system and communication protocols carefully is important to ensure that it works effectively. Overall, CQRS is a powerful architecture pattern that can improve the scalability and performance of microservices. If you are working on a microservices project, it is worth considering whether CQRS could be a good fit for your system. As business continue to adopt microservice architecture, it's important to consider the best approach for handling data consistency and reliability across distributed services. This is where the SAGA architecture patterns comes in. The SAGA pattern provides a way to manage transactions across distributed services. It breaks down a complex transaction into the series of smaller independent transactions, each with own compensating transaction. If a step in the process fails, the compensating transaction can be executed to undo the previous step. With SAGA, each service can perform its part of the transaction with the assurance that the overall transaction will be completed or rolled back if any service fails. Benefits of implementing SAGA: provides a way of handling complex transactions across multiple microservices, helps to handle failures gracefully and ensures the data remains consistent, help avoid problems like data inconsistencies and lost updates, increases system resilience and make it more robust. Before implementing SAGA, you need to consider a few challenges: trades-off between consistency and performance, overhead of storing and managing the states, and additional complexity that will be added to the system. So that's a quick overview of some of the key design patterns and concepts that are essential for creating effective microservices architecture. Of course, this is just scratching of the surface of what's possible with microservices, and there are many other design patterns and best practices to explore. I hope this video has been helpful and wish you all the best to continue to explore and develop your microservices project. Thanks for watching.